20th. I kind of like this for modern installation. It's like very intimate setting. I want the talk to be more interactive in a way. Like we can discuss when you see anything that you want to know more right away, just raise your hand and we can talk about it. Don't need to wait for time for QA. I don't want to just be one-way communication kind of thing. So yeah, we can do that. So while we're waiting, how many of you have ever tried Taster before? Or is this the first time you're doing it? Have you tried? Did you try? Can you raise your hand? No. So is it like it's totally new for you, right? Oh, that's cool. That's great. So we talk about it in detail. Because the talk to be very high level and great and just get started getting to know what it is, and then we can dive deeper into the documentation on your own later. So this talk is probably just to get an idea of what it is and what you can do with it, or like see if it's possible to even extend it to support other chains and stuff. Because right now, Taster only support osmosis at the moment. Okay, I think it's about time. So let's get started. Um, so as you can see on the slide, I'm going to talk about Taster, CosmWasm integration testing with appchain. So and my name is Boss. You can follow me on Twitter. I BossPK. A little bit about me. So I build this stuff on Osmosis, right? Which is Taster Osmosis STD, which is basically generate all the types from proto files, and making it CosmWasm compatible, which basically having a lot of purpose function. So interact with Osmosis from smart contracts, and also Beaker, which is basically hard hat. I just copy hard hat for CosmWasm, basically shamelessly. But today our focus is going to be Taster. So a little bit of a background. Like about a year ago, Sunny was working on this contract, Token Factory issue. You guys know what Token Factory module is? Yes? Okay. So as you know it, right? Token Factory is not really a it's not really a like CPU20 where it's a smart contract, right? You have to in order to interact with it, you have to kind of send messages to the custom module on the chain to make it work. And then when you try to taste it, right? If you try to taste it with zero amount of taste, you're probably not being able to fully taste it because it doesn't have the simulation of Token Factory model at the moment. You might need to customize it, write your own simulation for Token Factory, or you might want to spin up the whole local osmosis, spin up your Docker, deploy your contract, and all this kind of stuff, which has a very high latency in order to sort of taste a very simple logic or taste a lot of cases, and the feedback loop is going to be slow. So what Sunny did back then was like doing this. So basically writing code taste. Alex also do the same thing, just told me like yesterday. Basically writing code test, which I didn't know back then it's possible. So basically, it's basically calling keepers and all this kind of stuff and records in the chain code from chain code, and then upload contract, doing all this kind of stuff. Send messages. Basically, you write raw JSON into it to interact with the contract, which I think is kind of painful. So what if you can do all this thing in Rust, because we already have types in the defining contract and all this kind of stuff for the messages, and yeah, that would be cool. So how can we do that? So after that discussion with Sunny, so I come up with the idea of taste tool, which is basically doing this, right? So I create a wrapper basically around an import osmosis module, import osmosis package in Go, and then export like some of the generic functions like execute, sending messages, queries, like very basic ones where you can do almost anything interacting with the chain, and then export them as a C like dynamic libraries, and linking it back to Rust code, which is basically running a sort of URS file where it builds that Go code, and then those sort of simply dynamic link it back into Rust land, and then it's doing apply basically for a function invocation. And then what it is, and taste tool is actually having all the bindings definition for interacting with that dilib, and it contains chain agnostic logic. So the taste tool crate, you can put that and then build your own kind of own chain taste tool. If that makes sense for you, you can do that as well. It's not very complicated though. You could look at the osmosis taste tool for an example, right? So far, any question? No, it's good so far. Cool. So, okay, that's pretty much how it works. Let's see in the deeper detail, like when to use it, why you should use it. Sometimes you might not want to use it, right? For example, your contract doesn't really involve calling a lot of custom model logic. You just basically delete bands, and which CDB multitask already cover that. If that's the case for you, you don't need to use Taste2, because like Taste2 is going to be a little bit slower than CDB multitask, because all the FI and starting the chain process and all this kind of stuff. So, but for this particular example, I'm going to try to outline what kind of case where it makes sense to use Taste2. Okay. So this is a very kind of experimental contract where I'm trying to use Token Factory to create a emulate an NFT. So Token Factory, if you have a contract that mints only one token out of Token Factory with this thing on, and can never mint again. And we're trying to set kind of minter royalty. So whoever mints this NFT, every single time it gets out, the minter will get a royalty asset. So let's look at the contract. So on an instantiate, you just save the minter and save the minter royalty out of the instantiate message, and then send the message to create the norm, which is a Token Factory started message. And then at the reply endpoint, after creating norm successful, we want to mint them and set before send book, which before send book will be on osmosis on V17. It's not there at the moment, but it's a very good example you know, like good use case for taster, basically. So as you can see now, there are a lot of, sending message to token factory. We want to see if the norm is really being created. If we only unit test it, you don't know, right? You can only expect that message creating norm is in the response, and you don't really know if this type is actually doing the right thing. If this message is actually doing the right thing, right? Or if it's really trigger the reply endpoint, is it going to mint one token after that? Really? Is it going to set the before set book? You never know if you just unit test it or using pseudo multitask. Also, in pseudo messages, this is an endpoint that entry point that is being called by the chain, right? This message is sent from the chain, and this basically says after we register the set before sample, it will send this message, and we can say, oh, if the sender is not this contract and or the receiver is not this contract, it's going to be unauthorized, which is basically trying to prevent just transferring token for version and only restricted transferring through this contract, so that we can ensure that the minter is actually getting royalty. So then we only restrict the selling and buying process through this contract. We cannot, as you can see, we cannot transfer by normal means anymore. But then basically just sell it. Just when we trigger the sale, it's basically save the information from the seller, who sells it at what price, and the buyer is basically at buy. It's basically calculate and clean up the sale that it just saved, and then send NFT to buyer, send the pay price minus minter royalty to the seller, and send minter royalty to the minter. All this kind of stuff is going to as before, you can only expect if the message is correct, if it's a unit test. But with taster, you can actually see if the account is really having a change of balances, right? So let's taste them. So this is the how the tastes look like. So we basically when we say osmosis takes app new, it's basically spin up a validator inside this single process, and set all the keepers and all this kind of stuff up. So the app has an ability to init new accounts with some your optional in it. It can store code and all this kind of stuff, which is similar to how multitask does things. Basically store code and instantiate the contract. And we can taste that. Well, if I just bank send for whatever reason from the minter to user 0 without going through the selling and buying process, you can't do that because it's get blocked. You just expect the error message to be the same as defined. And this as you can see it's like this execute. It's not just going through the execute endpoint. It's actually trigger the pseudo block default center as well, right? So that's why this error is coming up. If we just unit test it, this error will not come up, right? And we can try complete the sale once. So we sell and we buy it. Nothing very interesting happened. You can assert things over here. But if we sell again, and the seller is not the minter anymore, we can expect that part of um, the part of the price goes to the minter, and the remaining parts go to the seller, right? So yeah, that's basically how taster looks like in practice. Um, and you might want to take a picture of this list of repos if you're interested in. Whereas um, there are recent example of using taster and vehicle based. So cool. So to summarize, taster provides fast feedback for CosmWasm testing against appchain logic, right? And it has a generic interface to appchain interface. It's chain agnostic at core, so you can treat it as an SDK to build the taster version. So it's not limited to osmosis. It's just osmosis really limited at the moment. Um, and just talked about it yesterday, basically, like how to make this work with IBC. So if you have like an IBC contract, and there are contracts in different chains, and you want them to interact with each other, how can you taste it like in Rustland, basically? So that's what I'm going to look into it more after this conference. And also, there are a lot of feedbacks on debugging because we just deploy a WASM file into the process, and all the debugger doesn't work anymore. So that's what I'm going to look into as well. A lot of interesting to work on afterwards. So if you have any ideas, you can share with me as well. And turns out it's just a pretty fast talk. That's all I have for today. But if you have anything you want to discuss with me, feel free to ask away. Yes.
I mean, first of all, just thank you for implementing this. Just want to say I've used this at Injective already. It has been extremely useful. Going from the old way, with the chain integration was on both sides, to this one. So I guess that's my question. I think, is there still ever a use case you think you still use the old way in Go? Or I guess testing makes this more sense for all cases, right?
That's an interesting question. I think that might be, I don't know, because like how case service implemented is like trying to remove, like only provides a very generic interface to the chain. You cannot do everything in trying to sort of like if you are heavily rely on some of the configuration where you have to change things in your Go side on the chain code side, or state logic and all this kind of stuff. It's not possible at the moment. You can only go that is being exposed normally, like sending message and all this kind of stuff. So yeah, those things is not available at the moment, and I think it's quite tricky to expose it. So yeah. So, but in general, I don't think there will be those kind of cases. Or do you think otherwise? Let me know, because if it's the case, I will try to find a way to make it happen. Yes.
Well, thanks a lot. This is an amazing tool. Very much looking forward to use it. And my question is, how do you integrate it into the Go chain? Is this on the SDK level or below?
Sorry. So how can we integrate it with the blockchain on the SDK level? Can you elaborate on that?
And there are multiple entry points that you could use. So you could use inside message, transfer to commit EFT, or you could just send a message to the SDK entry points, or keeper you're not using, but how do you call from Rust into the Go?
Right. The current interface is basically just using deliver th, request deliver th message. So I can show you the code. This is how it looks like. So small. It's actually the simpler. It's in here with osmosis taste tube, and you can go to main web terminal. So this is what it is. It's basically set things up, and then when it does things like execute, it's basically this, right? So request deliver tx, ABCI request deliver tx. So it sends as a basic simple encoded string of those bytes, and then proto unmatched array, and just run app.derivatives basically. That's all it is. And encode it with some error flags and send it back. And the Rust line is basically trying to decode it as in like okay or error, things like that. That's very simple.
Yeah, it sounds like
Anything else? No? You good? Cool. Thanks a lot.